Solving trigonometric equations, worksheet 1 solutions, right? So I hope most of you must have got all your problems from the worksheet 1. They were quite simple, straightforward questions. So we are basically giving you practice on primary trigonometric ratios, and that too with answers which could be found from the special triangles, correct? So it's a practice to understand in which quadrant the trigonometric ratios are positive or negative, and then use of your special triangles, correct? So that is the whole idea of worksheet 1. It has been made in a way so that you get used to the terms and to write all possible solutions, right? Now here we have solve for x in the interval 0 to 2 pi. Those of you who are not using radians, they can write their answers in degrees. That means from 0 degrees to 360 degrees, okay? So that's a note here to remember. I should have mentioned both right in the very beginning. Anyway, so you have to give solutions, all possible solutions from 0 degrees to 360 degrees. Now, most of you must have got these questions right, but here is a mistake which some could have done. Now, when we write cos square x equals to cos x, what they do is they write cos x equals, they cancel out one cos x, right? And then say cos x is equal to 1 and cos x is 1 at this, and those are the solutions. So I will show you the solution and then you will realize your mistake, right? So now let's try to solve this equation. So let me start by writing cos square x equals to cos x, right? Let's bring cos x to the left side. Then the equation becomes cos square x minus cos x equals to 0, right? And now we can factor cos x from here, right? If you factor cos x, what do you get? You get cos x minus 1 equals to 0, correct? Now, from this equation, you get two possible factors, right? One factor is cos x, the other one is cos x minus 1. So we have set of solutions, right? So one is that cos x could be 0, right? So one possible solution is that cos x equals to 0. And the other possible is that cos x minus 1 equal to 0, correct? So those of you who will cancel cos x will not get these solutions. They will only get that solution, which is, I'm again writing cos x equals to 1, right? If you cancel, you straight away get this. So what I want to highlight here is that in all these trigonometric equations, if there is an opportunity to cancel, don't do that. Bring them to one side, take a common factor, because that common factor is part of your solution, okay? That is most important. So this is what is a learning from this particular example, right? So you have two possible answers. Now the second part is, it's always good to make quadrants and then figure out where this answer should be, right? And in this particular case, what we can also do is, we can actually see our cosine graph, right? You know the cosine graph is something like this. Correct. So from here, you know it is 1 here, minus 1 here, and 0 at these points, correct? So these points, that is your time period of 2 pi, right? So this is, I should write 2 pi here, I said, okay, that's fine. So this is like pi by 2, right? This is pi, that is, okay, 2 pi by 2, and this is 3 pi by 2, correct? So that is in radians, correct? And you're looking for answers when cos x is 0, that means that set is one set of answers, and the other set of answers is when cos x is equal to 1, and that is these two sets of answers, correct? So we have 4 answers or 4 solutions to this equation. So that is in radians, right? So let me write down all the possible answers here. So our answers in radians are 0, pi by 2, 3 pi by 2, and 2 pi, correct? Because cos x could be 0 or could be 1, giving us all these possible answers, right? And if you write these answers in degrees, then also you know what the answers are. So in degrees, the answers are 0 degrees, right? and then this is 90 degrees for you, and that is 270 degrees, and then 2 pi, which is 360 degrees. So these are all the possible solutions for the given equation cos square x equals to cos x, correct? The idea here is to teach you different ways of looking at this solution, right? So in this particular example, I purposely took the graph as such, showed you the graph so that it becomes visual for you and figure out the answers, correct? That's a good way of doing it, okay? I hope you learn from this, and let's move on to the next question. Thank you.